Alright, those of you who were here yesterday, okay, we obviously already know some of this. We went over it. Those of you who were not, okay, you need to make sure you're taking good notes here. Okay, we're talking 9.6, solving right triangles. To this point, we've already been able to pretty much solve a right triangle. Okay, if you were given two sides, you could find the third side, right? If you were given two angles, you could find the third angle. If you were given two angles and one side, you could use sine, cosine, tangent, find the other two sides, and then just subtract and find the third angle. Okay? The difference today is they're only going to give you, at times, one angle. You have to find the other two. Okay, so that's what's new about today. Now, with that, the first thing we need to talk about is just solving a right triangle. What does that mean? If you were here yesterday, raise your hand and tell me what solving a right triangle means. Travis? Okay, so you're finding all sides and all angles of a triangle, right? Or a right triangle. Okay, so how many answers are you going to have when they ask you to solve a right triangle? 6. You're going to have 3 angles and you're going to have 3 sides, right? Okay, so when they ask you to solve a right triangle, you need to find all 3 angles and all 3 sides. So you're finding all angles and sides. Okay. Alright, so if they give me a triangle here, and this isn't in your book, I'm just making this one up as I go. Okay, maybe it's triangle ABC. Okay, typically we see the right angle as C, but it really doesn't matter. And let's say they go ahead and tell me that this is 26 and this is 12. Okay, our goal here is to solve this right triangle. So as I'm doing this, obviously I'm going to need angles A, B, and C, right? Oops. So I'm going to need angle A, I'm going to need angle B, and I'm going to need angle C. And I'm also going to need side A, side B, and side C. Okay. If you wanted to label this like AB, segment AB, segment BC, segment AC, that's fine as well. I don't care how you label it, as long as I know what you're talking about. Okay. Are there some of those things that we already know? Yeah, Lainey, give me one. Side A is what? It's always opposite. So opposite of angle A is side A. So side A is actually 12. Okay, what else? 26 is side B. And then what else do I know? Angle B is 90 degrees. Okay? You are going to have to be given at least 3 things to be able to do this. Okay? So, because one thing you have to know, none of this works if you don't have a right angle, right? So they're always going to tell you that it's a right angle. And then from there, they might give you 2 sides. They might give you 2 angles. They might give you 1 angle and 1 side. Okay? Any of that would be fair game for them to give you. Okay? But you're going to have to start with 3 things. Okay? So automatically, you already have half your stuff filled in, right? Okay, so we just have to find our other things. Let's go ahead and find C, because I think to most of us that's going to be the easiest. How do I find C? Side C. How do I find this missing side? Now, can I use sine, cosine, tangent if I don't know these angles? No. Taylor? Set it up for me then. Good. 12 squared is 144 plus c squared equals, I don't know that one. Yeah. 676. Okay. Subtract 144, so a c squared equals 2, 3, 5. So c equals the square root of 532. We're probably not lucky enough for that to be a perfect square. Decimal. Okay. But since I didn't use sine, cosine, tangent, we don't really want a decimal. Okay, so let's keep this exact here. What do I need to try to do? Reduce my radical. So the smallest one that might come out of that is a 4. Looks like it might. So let's try that. Because 4 comes out of 32. Does it come out of 532? How many times? 100 and what? Square root of 4 is? 133 doesn't sound like anything comes out of it. Anybody find anything? I don't think it does. Okay, so my side length is 2 square roots of 133. Okay. We all should have been able to get to that. Okay. The next thing that those of you who were gone yesterday wouldn't be able to get to is these angle measures. We have to now find angle A and angle C. Okay? And this is the new stuff here for us. What function could I use for angle A since I know these two? What trig function would contain those two? Sine, right? Because I have the opposite and the hypotenuse. Everybody agree with that? Opposite, hypotenuse. Now I could use C now, okay, but I want you to be careful with that because if you would have happened to get that wrong answer and you use it, now everything's going to be wrong, right? Okay, so try your best not to use the answers that you came up with on side lengths. Okay, but I do know that the sine of A is equal to 12 over 26, correct? That's a fact. Okay, most of you who were gone yesterday aren't really going to understand why we're doing that yet. Okay, but we're getting there. Now, just like if I would have like 3x equals 12, what would you do to solve this? You divide, because multiplication and division are opposites of each other, right? They're like inverses of each other. Okay, that's the opposite thing. It's getting you back to where you started. Okay, if you were adding, you would subtract. If you were squaring, you would square root. Okay, you're looking to find the inverse. So we have to find the inverse of the sine. What's the opposite of doing the sine? It's doing the inverse sine. Okay, so on your calculators, under the sine button, you'll have to hit the second button to get there. But on that sine button, you also have a button that looks like this. It's the inverse sine. Okay? Just like if you were to multiply something that was being divided, or you divide something that was being multiplied, those cancel each other out, don't they? When multiplication, division, they cancel each other out. The inverse sine and the regular sine are going to cancel each other out. Okay? But with our math knowledge, we know that if I did it to the left side, I also have to do it to the right side, correct? So I actually have what left on the left side? Just A. So I have A equals, then I have the inverse sine of 12 over 26. And this we just need to type straight into our calculator. So I have inverse sine 12 divided by 26, close my parenthesis, and I get A equals what? 27.5. What did I find right there? Angle. So I need to make sure what's on this? Degrees. Good. I typed just this exactly. Inverse sine of 12 over 26. So angle A is 27.5 degrees. Okay. Now, I know for the last week or so I've been telling you if you get a rounded answer, don't use it, right? Yep. Okay. But right here, if this is 27.5 degrees, in a triangle, these angles have to add up to exactly 180, right? They can't add up to 180.1. They can't add up to 179.9. They have to be exactly 180, correct? So could I use this one to make sure that they add to 180 and just subtract here? Yes, you could. Okay, I'm not going to right now. I'm going to go through this process one more time so we can see it one more time. Okay, but you could just take 90 minus 27.5 because these two angles have to add to 90, correct? Because that one's already 90. Okay, so let's go ahead and take a look. Let's do angle C now. I'm going to go ahead and actually just push this stuff down here so it's out of our way, and we'll use the same spot. So looking at angle C, I have 12 and 26 still. I'm trying to avoid using C if possible. What function uses these two? Cosine. It's not sine. Definitely not sin. It's sine maybe. But why is it not sine? Somebody explain to me why it's not sine. Carly? 12 is the adjacent. It was the opposite from A, but now we're on C. So now it's adjacent to C. Okay? So I want the cosine of C equals what? Good, 12 over 26 because it's adjacent over hypotenuse with SOHCAHTOA. Okay? And so most of you aren't going to have to do as much work as we did on this one. I'm actually going to have that C equals the inverse cosine of 12 over 26, correct? Okay. And inverse cosine 12 over 26 gives me 62.5 degrees. Okay. Make sure, do those two things add to exactly 90? Yep. Yes, they do. Okay, so just double check it. Notice I have how many answers? 6. You should have 6 answers every single time that it asks you to solve the right triangle. Okay. Most of that we've already done, correct? The only difference is now you're using your inverse trig functions to be able to find angle measures. Okay, so those of you who weren't here, I want to make sure you have this written down. Okay? If you're finding sine, cosine, and tangent, so like if they just say find the sine, cosine, tangent of the acute angles, do you ever actually use your sine, cosine, tangent buttons on your calculator? No. Okay? If you wanted to find the cosine of angle C, you just take 12 and you divide it by 26, right? Okay? Don't confuse that. Hey, if you're finding sine, cosine, tangent, you never use the trig functions or the buttons on your calculator, except if they gave you something like this, right? If they said to find the sine of 59 degrees, you would just type it in your calculator, sine 59 degrees, right? Okay. Be careful on your homework. The first group of problems, they look like this, but they ask you to find the angle measure. What would you do to find the angle measure? Right. It's going to be like, it's actually going to look like this. It's actually going to be like sine of A equals 0.15. You do the inverse sine of 0.15 to find the angle A, right? Okay, those were kind of confusing for some students. Okay, the other thing, use the inverse trig functions when you're finding angle measures. Okay, that's a good rule for us. Only use the inverse buttons if you're finding angle measures. Okay, and then the last rule for us, use your regular trig functions when you're finding side lengths. So if you're trying to come up with side lengths using sine, cosine, tangent, just use your regular trig functions. So write those down real quick. I'm going to go ahead and let you guys get started on your assignment here. If you have questions, make sure you let me know. You have most of the class here to work.